Hello friends, today I am solving a problem from design of welded joint. So this is the sketch which will be given on your question paper. So here I have used black ink pen to write the values whichever given in on your question paper. So these are the black ink numbers, well, the question is, determine the size of weld required for an eccentrically loaded weld. The allowable stress in the weld is 75 newtons per millimeter square. And so hence, see, allowable shear stress in the weld. This is the data given. Tau dash is equal to 75 newtons per millimeter square. And initially we will calculate the center of gravity of the weld. So the term nx is distance of cg from the top, this distance from here to here, and ny is distance of cg from left, from this point to this point to this. So that will give you the cg value, that will fetch the value of cg, or it will locate the cg. So for that, nx is 75 by 2, that is m by 2. Okay, so this m and n which I have considered is to make it easy to use your data handbook, because the notations which I have used are in m and n, so you will come to know during this solution. So next, ny is equal to n square by 2n plus m. So n square, this value divided by 2n plus m. N value is 50 and m is 75. So you will get this ny value, 14.286 millimeter, and this equation you will get in page 74 and table number 6.7. This is the third edition of design data handbook. So in fourth edition the page number may vary, and make sure that third edition and fourth edition equations are same, because in fourth edition some errors are there in symbols which we have used, like the tau dash, and there are some errors, so please check it. So next, ny value we got. So next, this is ny, nx. To get this value, what we have to do is n minus ny. So this is already available here, the full value is available. 50 minus ny value will give you this value. Okay, so next, to find r, e and cos theta, this is the equation. So this is not in your data handbook, so please remember this. Substitute the values and you'll get the value of r equal to 51.785 millimeter. Next is e is the eccentricity, that is the distance between the load applied and the center of gravity. Load applied is here and center of gravity is here, so this plus 100, it is, yeah, in terms of equation I have written. This is not available on your data handbook. For your convenience I have written it. So e is equal to 100 plus 50 minus 14.286, that is this value. You will get 135.714 millimeters eccentricity. And next, cos theta is equal to n minus ny by r. So this equation is also not available on your data handbook. So cos theta value you will get, but make sure that while using calculator, this should be in degree, not in radians. Okay, you have to keep it in degree mode. Next, direct shear load per unit length of weld. Direct shear load. So applied load, the notations which I am taking is P and PD for direct shear load per unit length of weld for convenience. So PD is equal to P by L, that is 25,000 divided by L. L is length of weld, total length, that is 50 plus 75, this portion, and this 50. Okay, that is 50 plus 75 plus 50 is 175 millimeters. So next, PD, that is a direct shear load per unit length of weld. So you'll get, substitute these values, the P and L value, you'll get the PD value. Next, load due to torsional or twisting moment per unit length of weld. Torsion or twisting moment, I have considered Pn. So this equation is available on your data handbook. So that is, yeah, this is a sketch and this is J. J is polar moment of inertia. Okay, polar moment of inertia in torsion J. Here you have the equation. So here they have considered T, that is depth of weld. T is depth of weld. So here they did not mention anything regarding the depth, so we will consider it as 1. Okay, and all n and m values are available, n and m, so substitute that and you will get the value of j, the value of j. So next, pn is this one, load due to torsional or twisting moment per unit length of weld. So P you have E, R and J, so you will get the Pn value. Okay, so next is resultant load per unit length of weld, that is PR, resultant load. So this equation is there on your data handbook. It's here. So here, see the equation. They've given the maximum resultant shear stress, tau max they have given, is equal to square root of tau 1 square plus tau double dash square plus 2 tau 1 tau dash or tau double dash cos theta. So but this is equation 6.3, but here I have made a little modification because we have used this PD PN here in our calculation. So PD and Pn, so accordingly I'll write the equation. PR, that is resultant load, is equal to square root of PD square plus Pn square plus 2 PD Pn cos theta. Substitute the value and you will get the PR, resultant load. Size of weld, see, size of weld I have taken n dash because initially I have taken this width as n, so I'll take this as n dash. Okay, so this equation is also available, page 6 point, sorry, equation 6.1, page 70. This equation, okay, tau dash is equal to f by b cos 45 degree L. This is original, but according to our considered terms, we will I have modified this equation. So tau dash is equal to PR by n dash cos 45 degree L. So here the L value is not given, that is unit length, per unit length it is. So PR is what we have calculated as per unit length, of weld. So unit length means 1 mm. So that is see here while you consider this 891.1, fraction matters. When you calculate this, you will get some fractions. So how you modify, depending on that your answer varies. You can consider 4 digit after this 4 digits. Okay, if you consider 2 also is sufficient, so accordingly your answer will also get varied. So now I have to calculate n dash, so that is substitute all the values, and size of the weld is n dash is equal to 16.8 millimeters. Thank you.